We are continuing in our Chapter 4 for geometry class. Chapter 4 is all about proving triangles congruent, and we are now going to start learning some postulates with that. So today I'd like for you to be able to show that triangles are congruent through the side-side-side postulate as well as the side-angle-side postulate. Let's jump right in and talk about the side-side-side postulate first. And it says, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So let's look at this image. I have the hypothesis, and in this I have AB is congruent to DF, they're both 4. And then I have BC is congruent to DE, they're both 6. And I also have AC is congruent to EF, they're both 7. Because I now have 3 pairs of congruent sides, I can then say, oh, triangle ABC is congruent to triangle. Now don't forget that we need to put in the same order. So I'm going from A to B to C, which is the 4-sided, and then the 6-sided or the 4 length and the 6 length sides. So that means I need to go F, D, E for this one. So order does matter. If you get it in the wrong order, then it will be incorrect. Let's put side, side, side into action. It says use side, side, side to explain why triangle ABC is congruent to triangle DBC. So what do we know so far? I know from A to B and from B to D are congruent. That's from my image, so I'm just going to write it out. I know AB is congruent to segment BD. And that's just marked. That's why I know those two are congruent to each other. I also know from A to C is congruent from C to D. But to be able to use side, 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 I don't just need 2 pairs, I need 3 pairs. Well, the way I'm going to get that third pair is by looking at this middle line right here, line BC. Now, line BC is congruent to itself. This is very similar when you're doing rhyme schemes and you say to yourself, oh, blue rhymes with blue. It's the same word, sure, but it still rhymes with itself. So I can say BC is congruent to BC. That is using the reflexive property. So I'm now going to say segment BC is congruent to segment BC, and that is shared in both of these triangles. I'll put in parentheses reflexive property just to remind you. So now I have 3 pairs of corresponding sides that are congruent. So I am going to say triangle ABC is congruent to triangle DBC because it has 3 pairs of corresponding and congruent sides. Essentially, because of side, side, side. Let's look at triangle congruence in a real-world example. The British flag. It says the British flag has many triangles in it. The marked triangles in the image are right triangles, and they both have leg lengths of 3 and 4. Are they congruent? Why or why not? Let me mark in this image a little better for you. It's where these little dashes are. So we are looking at this triangle and this triangle. And it gave us some valuable information. To begin with, it said that they are right triangles, which means we have 90-degree angles right here and right here. It also said both of them had leg lengths of 3 and 4, so I'm going to label that as well. What we want to figure out is, are these congruent? Well, do they have 3 pairs of congruent sides? Currently, we only were given two sides of each triangle. But we do have a strategy to figure out the third. Remember the Pythagorean theorem is a squared plus b squared equals c squared. So I could say, oh, 3 squared plus 4 squared equals this guy squared. I'll just label him c. And we'll be able to figure out what that missing side is. So 3 squared plus 4 squared is equal to c squared. That's 9 plus 16 is equal to c squared. So now I need to square root both sides. And I get c is equal to 5. C is equal to 5. Well, if c is equal to 5 over here, and this has nothing but the same numbers, like it's literally the same exact numbers, then I'm going to say c is also equal to 5 over there. So now I have a 3, 4, 5 triangle and a 3, 4, 5 triangle. They both have the same exact side lengths. So I am going to say, yes, the triangles are congruent because they share 3 pairs of congruent sides. And it's as simple as that. Now, not only do we have side, 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 we also have side, angle, side. So this is going to be exactly what you think it is. You're going to be given a side, and then an angle, and then another side. So this postulate says, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Okay, I want to highlight a word for you, and it is very valuable. This is going to totally change what this means if you don't include it. When it says included angle, it means in between. So I have 2 sides, and I need the angle that I know to be in between them. So let's look at this image. I know this side, and I know this side. Notice how the angle A is formed, and it's in the middle of these guys. B is not in the middle of them. C is not in the middle of them. So that's why right now I have side, angle, side for this one. Over here, I also have angle E being on the middle. So I have side, angle, side. Included means in between or in the middle. So if I have these 2 triangles, this one has side, angle, side in common with this one's side, angle, side. That must mean that triangle ABC is congruent to triangle EFD. Now remember, A has a mark and E has a mark, so I need to line them up. B is the side with 1 notch, so I need to go to F because that side only has 1 notch. And then I'm just using my leftover letter for D. Let's use side, angle, side in action. So it says use side, angle, side to explain why triangle XYZ is congruent to triangle VWZ. Well, right off the bat, we were given some pairs of congruent sides. So I'm going to use that information first. I have segment XZ is congruent to segment ZV. And I have segment WZ, that's this part right here, is congruent to segment ZY. So already I have 2 of the sides that are congruent. I need to figure out how can I get this angle right here to be congruent. Well, notice what type of angles they are. These guys are vertical angles. So I'm going to make a little note for you to remind you. Vertical angles are congruent. That's not changing anytime soon. So now I could say angle XZY and angle WZV are congruent. So I'm going to say angle XCY is congruent to angle WZV. Why? Because they are vertical angles. Okay. Looking at this image, I have a side, an interior angle, and a side. And then over here I have a side, an interior angle, and a side. So the pieces of these two triangles that are congruent follow the pattern of side angle side, which means now that triangle XYZ is congruent to triangle VWZ by side angle side. For our last example, I'd like for you to just be able to identify if you could or couldn't use side angle side or side 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 to show that two triangles are congruent. So looking at this, we have triangle ABC and FED. Okay, we have an angle in common, and we have a side in common, and then we have another side in common. Notice how the angle that we know is in between the two sides that are congruent to each other. This means that I am able to use side angle side. Now looking at this next image, it's a little small, so let me make it larger for you. The markings in the image. Okay, I have a side that's congruent and a side that's congruent. Then I have another side that's congruent and another side that's congruent. But then I have this angle out here. This angle is not an inclusive angle or an included angle. This angle is on the outside of the two sides that I know. So this means there is not enough information. Looking at problem C, I know from A to B is 1 notch, and then down here from D to E is also 1 notch. From B to C is 2, from E to F is 2, and then I have 3 right here. So I have 3 pairs of corresponding sides in this image, which means I have side, side, side congruency. Let's look at this last image. I have a pair of congruent sides, and it looks like that's just about it. But I do have one more thing that I could say. This angle and this angle are congruent because of vertical angles. But that is all that I am able to mark on this image. I'm not able to conclude anything else because I'm not told that the lines are parallel. I'm not really told enough information to conclude anything else about these triangles. So all I have is one side and one angle, and that is not enough information for me to show that these triangles are congruent. So I'm going to say not enough information. And there we have it. We are done with today's notes. I hope that this is making sense and that you enjoy the rest of your evening. See you later. Bye.